Hello everyone! Today, we're peeling back the lid on one of the world's most popular condiments, mayonnaise. Often taken for granted as a creamy spread for sandwiches, salads, and more, mayonnaise is actually a sophisticated emulsion of key ingredients. In this video, we'll walk you through a modern mayonnaise factory to see exactly what goes into that jar of smooth, velvety goodness: eggs, oil, vinegar, and a bit of culinary chemistry. By the end, you'll appreciate how each ingredient and step come together to create the iconic, creamy condiment we know and love. Mayonnaise is ubiquitous, from quick service restaurants to home kitchens. Whether spread on sandwiches, used as a base for dressings like ranch or aioli, or folded into sauces and dips, Mayo's velvety texture and subtle tang have made it a staple worldwide. Variants abound: light mayo, vegan substitutes, flavored additions, but the foundation remains similar: oil, egg, or egg alternatives, acid, and seasonings. Despite seeming simple, achieving perfect stability and consistency requires precise ingredient ratios and emulsification techniques. Factories harness advanced mixing equipment, laboratory analysis, and automated filling lines to meet massive demand across global markets. At its core, mayonnaise is an emulsion, tiny droplets of oil suspended in an aqueous phase, egg and acid. This structure is stabilized by the emulsifying properties of egg yolks, lecithin, and proteins. The result? A thick, creamy sauce that doesn't separate into oil and water. Historically believed to have origins in European cuisine, mayonnaise's mainstream popularity spread across continents, becoming a key condiment in American, European, and Asian dishes alike. Manufacturers scale up this concept by carefully controlling proportions of ingredients: egg yolks or whole eggs for emulsification, color, and flavor; vegetable oil, soybean, rapeseed canola, or a blend as the main fat component; acidic liquids, vinegar, lemon juice for tanginess and pH control; salt, sugar, and spices to fine-tune taste. Imagine large stainless steel mixing tanks, computerized temperature controls, and conveyor belts full of jars. Mayonnaise factories typically receive deliveries of bulk raw materials: pallets of eggs, liquid pasteurized or dried egg powders in some cases, large drums of vegetable oil, barrels of vinegar. Incoming trucks unload these ingredients at designated stations. Tech-savvy facilities track inventory digitally, ensuring each batch follows exact recipes. On-site labs test ingredients for purity, freshness, and compliance with microbiological standards. Traditional mayonnaise calls for raw egg yolk, but modern safety regulations often require pasteurized eggs. Factories might source liquid pasteurized yolks or whole eggs stored in refrigerated tanks. If fresh eggs are used, they're carefully washed, cracked mechanically or by specialized automated lines, separated into whites and yolks if needed, and then pasteurized. Pasteurization kills potential pathogens like salmonella, safeguarding consumers. This step is critical, as mayonnaise is served cold without further cooking. Laboratories might also monitor egg quality, protein content, color, or any off odors that could affect final taste. Oil makes up the majority of mayonnaise by weight, often 65 to 80% in standard formulas. Factories store large volumes of neutral flavored oil, e.g., soybean or canola, in silo-like tanks. Pumps transfer oil into mixing vats, controlled by flow meters that measure precise amounts. Some premium brands may blend olive oil or specialty oils for distinctive taste. Over time, an oil's properties like peroxide values or rancidity markers are tested in a factory lab to guarantee freshness and minimal off flavors. The right oil ensures a stable emulsion with a consistent mouthfeel. Vinegar, often distilled white vinegar or lemon juice concentrate, provides the tang and pH control in mayonnaise. The acid level helps preserve mayo by inhibiting bacterial growth. Factories calibrate acid addition meticulously. Too little results in bland or unsafe product. Too much yields overly sharp taste or watery texture. Salt, sugar, mustard, or other spices go into the mix for flavor balance. Some recipes include stabilizers like xanthan gum or modified starch to ensure thicker consistency, especially in low-fat or light mayo variants. Each brand's signature taste arises from carefully honed ratios of sweet, salty, and sour elements. At the core of mayo production is the emulsion stage. Large mixing vessels, some with high shear blades, combine egg, acid, and seasonings into a watery base. Oil is then introduced gradually. As high-speed mixers shear the oil droplets, they're trapped in the egg's lecithin, forming a stable emulsion. Key parameters include mixer speed, high enough to create uniform droplets, but not so high as to over-shear or incorporate too much air. Temperature, typically cool, maintaining egg protein integrity. Addition rate, oil must be added slowly or the emulsion could break. The factory's control system might display real-time torque or viscosity readings, letting operators know if the emulsion thickens to the desired consistency. It's akin to a scaled-up version of whisking by hand, just far more precise and enormous in volume. As each batch forms, technicians pull samples to measure pH, should remain around 3.5 to 4.0 for safe, tangy mayo, and viscosity using instruments like a Brookfield viscometer. They also do taste tests to confirm flavor alignment with brand standards. Some labs measure droplet size distribution. A smaller droplet size typically yields smoother mayonnaise. If any parameter strays from specifications, pH too high, too runny, off flavor, the batch might be reworked, adding acid, adjusting oil, or in worse scenarios, scrapped. Consistency in taste, texture, and color across thousands of jars is paramount for brand reputation. Once the mixture meets the target specs, it's pumped through a final inline filter, removing lumps or foreign particles into a holding tank. Factories keep the mayonnaise under cool conditions to prolong shelf stability before bottling. Some lines incorporate nitrogen flushing to limit air contact, further boosting freshness. Workers or automated systems occasionally test synergy with additional flavors like garlic or chili if the brand offers spiced mayonnaise. The main portion, however, remains classic, waiting to fill jars or squeeze bottles on the packaging line. Plastic or glass containers feed from supply hoppers onto conveyor belts. The bottling machine dispenses measured amounts of mayonnaise at high speed, capping each container with a tamper-evident seal. Some systems use specialized nozzles that minimize air pockets or swirl patterns. In squeeze bottle production, attention to bottle shape ensures easy dispensing by consumers. Labels are affixed next, featuring brand logos, ingredient lists, nutritional facts, and best before dates. Factories use vision inspection to confirm correct label orientation, date code presence, and closure integrity. Any mislabeled or short-filled containers are ejected for rework. Traditional mayonnaise relies on acid and eggs properties for preservation. Some factories produce shelf-stable mayo sealed in sterile conditions with pasteurized eggs using higher acid content or preservatives. This allows them to store unopened containers at room temperature for months. Other lines produce fresh mayonnaise with minimal preservatives but requiring refrigeration from factory to retailer. This approach highlights a more artisanal egg-forward flavor but shortens shelf life. Either way, strict cold chain or sealed packaging is crucial to prevent microbial growth. Before dispatch, QA staff may open random jars to recheck consistency or weigh random samples for fill accuracy. Sensory tasting might confirm no off notes. All containers then move to palletizing areas, robots or mechanical arm-stacked boxes onto pallets, shrink wrapping for stability during shipping. Factories store pallets in climate-controlled warehouses until distribution. Large orders may ship via refrigerated trucks if mayonnaise demands continuous cool conditions. Alternatively, shelf-stable versions can handle standard shipping if sealed properly. Environmental considerations include responsibly sourced oils, perhaps non-GMO or from sustainable farmland, conscientious egg sourcing, cage-free or free-range hens if brand ethics align, and minimal packaging waste. Factories adopting advanced CIP clean-in-place systems reduce water usage, while high-tech mixing systems can cut energy consumption by optimizing motor speeds. Some brands highlight eco-friendly packaging, like lighter plastic or recycled materials, and rely on transparent supply chains for eggs. Consumer awareness about animal welfare and deforestation spurs producers to carefully choose suppliers for their key ingredients. Beyond classic full-fat mayo, factories create variants: light mayonnaise, lower oil content replaced with water or thickening agents, carefully rebalancing flavor and texture; eggless vegan mayo, substitutes like aquafaba, soy proteins, or pea proteins replicate eggs' emulsifying function. Perfect for plant-based or allergen-sensitive consumers. Flavored mayos, infusions of garlic, chipotle, wasabi, or herbs yield unique taste profiles. Some use color-coded packaging to differentiate from original versions. These alternative lines often run after standard production, cleaning mixing equipment thoroughly to avoid cross-contamination. Demand for specialty mayos continues expanding as dietary preferences diversify. Egg-based condiments risk contamination with salmonella if unsanitary conditions arise. Factories maintain strict HACCP protocols, focusing on each critical step: egg pasteurization, acid addition, constant cold chain. Metal detectors or X-ray scanners at packaging lines ensure no foreign objects slip into containers. Regular microtests confirm the product remains stable over its labeled shelf life. Regulatory bodies like the FDA in the US or EFSA in Europe impose guidelines on minimum egg content, fat percentage, and acidity to label a product mayonnaise. Factories meticulously track these parameters, guaranteeing compliance. Mayonnaise consumption stays strong globally, with emerging markets adopting Western condiments. Some consumers prefer bolder flavors or health-driven recipes, like avocado oil mayo. Meanwhile, e-commerce growth and meal kit deliveries expose mayo to new audiences. Factories, agile enough to adapt recipes, like low sodium or sugar-free, tap niche segments effectively. Collaborations with gourmet chefs or celebrities spawn limited edition mayos. Innovations like lacto-fermented or keto-friendly lines further expand brand identities. Despite these variations, the standard formula remains a kitchen mainstay for countless households. While artisan producers manually whisk small batches, big factories can churn out thousands of jars per hour, yet both share core principles: correct ingredient ratios, stable emulsion, and hygienic conditions. Some upscale brands differentiate by using local farm eggs and boutique oils. Marketing exclusivity. In contrast, mass market lines emphasize cost control, supply chain reliability, and robust distribution. Advanced AI or automation can analyze real-time emulsion stability, color, or jar fill. Trimming labor needs yet ensuring unwavering quality. Finished mayo typically arrives at supermarkets in jars or squeeze bottles. Factories coordinate shipments via trucks or container freight. Popular, established brands negotiate prime shelf space, while niche or premium lines might appear in smaller gourmet sections. Some factories provide private label manufacturing for big retailers. Similar recipes, different branding. Inventory turnover is swift as mayonnaise remains a staple in many recipes. Warehousing is simplified if the product is shelf-stable. Reefer or chilled logistics might be used for freshly made or short shelf life mayo variants. Consumers spread it on sandwiches, swirl it into dips, or whisk it into dressings. Chefs transform mayonnaise into aioli by adding garlic, or replicate international flavors with spices. Mayo's emulsifying nature also helps moisture retention in baked goods or roasted meats. Meanwhile, social media fosters creative uses, like grilled cheese with mayo instead of butter, or drizzle mayo sauce on sushi burritos. Factory outcomes matter. A stable, high-quality mayo ensures reliable performance under varied cooking temperatures, preserving flavor. Negative consumer experiences, e.g., runny or separated mayonnaise, can erode brand loyalty, underscoring the importance of consistent factory QA. From raw eggs and neutral oil to a creamy, stable spread, mayonnaise production is a testament to the magic of emulsion. Factories blend human know-how, like taste testing and final adjustments, with automation that measures out each droplet. The result is a condiment at once familiar and quietly complex, linking farm-fresh eggs to advanced mixing tanks in a single, delicious jar. If you've enjoyed peeking behind the scenes at mayonnaise production, consider subscribing for more in-depth stories of how our everyday staples are crafted. Share your thoughts. Do you have a favorite mayo brand or recipe hack? Next time you open that jar, remember the synergy of eggs, oil, acid, and skillful engineering that transforms simple ingredients into a creamy, savory indulgence.